I'm Professor Rad, and this is Precalc video 315, the sum and difference formulas. So far in our trigonometric videos, we've looked at definitions of trig functions, so defining the ratios of, sine of an angle, what that means, and so on. We've looked at some properties of trig functions, so things like the quotient properties, reciprocals, and Pythagorean, stuff like that. We've also looked at the unit circle, so some specific angle information and graphing trig functions. So now we're going to start moving into something that's called more like analytical trig. So we're going to be doing some more explorations with properties and identities and things, and applying them to solve equations and generate some new identities. So in this video and the two that follow it, we'll be looking at some new formulas, some new properties, and applying them to help us find some trig values, or to help us in the future find angles when we know the trig ratios. So in this video, we're going to cover the sum and difference formulas. There are 4 of them. So we have the sine of a sum, the sine of a difference, the cosine of a sum, and the cosine of a difference. So if you want to take a moment and jot these down, you can pause the video here to do that. So hopefully you've gotten those down. If you're in my class and you're using the trig formula kind of review packet, this is at the top of page 2. You'll find a spot for the sum and difference formulas. So here's how I remember the sum and difference formulas. So I noticed that there are some patterns between the 2 sine formulas. They both have sine cos and then sine cos. They both have sine of alpha, sine of beta, and cosine beta and cosine alpha. So you have an alpha and beta in each piece, right? And you have sine of both. You have sine of alpha and beta, and you have cosine of both, cosine and alpha and beta. So those are some general guidelines you want to keep in mind. The same is true for our cosines. We have here we have cosine of alpha and beta, sine of alpha and beta. So you have sine of both angles, you have both angles present in each chunk. So the way that I remember these is that for the sine sum and difference, it's sine cos same. And for cosine of the sum and difference, it's cos sine opposite. So we have sine cos, same operation. Sine cos, same operation. And then for cosine, you have cos sine opposite operation. And then cos sine opposite operation. So that's how I was able to remember this, because I have trouble memorizing stuff. So that's what I did. Sine is sine cos same, and cosine is cos sine opposite. So let's look at a couple of examples of applying the sum and difference formulas to find particular values. All right, for our first example, we've been asked to find cosine of 7 pi 12ths. Now you might be wondering, what does this have to do with sum and difference formulas? Because we don't have a sum or difference of angles up in here. However, our task is actually going to be to write it as a sum or difference and then apply the sum difference formulas. Here's why. So with 7 pi over 12, our goal is to take that angle, that fraction, 7/12, and write it as the sum or difference of angles we know information about. So for example, we know sine and cosine of pi halves, pi thirds, pi fourths, pi sixths, and integer multiples of pi. So our plan of attack is going to be, let's take this 12th and see if we can write it as a sum or difference of angles we know about. So here's one way you can go about doing this. It certainly isn't the only way, but this is the method that I usually use. So I'm going to think of 7/12 or 7 pi 12ths as 1 pi over 12 plus 6 pi over 12. So I'm going to start with 1 here and then 1 less here. So 1 less than 7 was 6. So if I add these, I'm going to get my 7 pi over 12. When I'm splitting these up, what I'm looking for in order for this to work is for both fractions to reduce to having a denominator that's 2, 3, 4, or 6, or just an integer multiple of pi, because those are angles we know about, so we can use that information to evaluate this expression. So we have good news, the 6 pi over 12 will reduce, but pi twelfths doesn't simplify anymore. And we don't know anything about twelfths. So then what I'm going to do is I'm going to increase the numerator here by 1 to get 2 pi over 12. And then I'll need 5 pi over 12 to get to 7 pi over 12, right? So 2 and 5 will give me that 7. This time we have good news that the 2 pi over 12 will reduce to being pi over 6, and we know stuff about sixths, but 5 pi over 12 does not reduce, so no dice. So I have 1 pi, 2 pi, let's try 3 pi. So 3 pi over 12, in order to get to 7, I'm going to have to add 4 pi over 12. And this will reduce because 3 goes into 12. This one will reduce because 4 goes into 12, and they add to the 7 pi 12ths. So this is the sum that I'm going to use to represent 7 pi over 12. So I'm going to rewrite cosine of 7 pi 12ths as cosine of 3 pi over 12 plus 4 pi over 12. And the 3 pi 12ths will reduce to pi fourths, and 4 pi 12ths will reduce to pi thirds. So we're going to write this as cosine of pi fourths plus pi thirds. Now we have cosine as a sum of angles that we know information about. So now we can apply our sum formula. So for cosine, cosine was cos, cosine, sine, opposite. So when we say cos, cos, we're going to mean cosine of the first angle, cosine of the second angle. So cosine of pi fourths, cosine of pi thirds. So our cos, cos. Then we have sine, sine. So sine of pi fourths, sine of pi thirds. And then opposite. So because this is a plus, we're going to have a minus. So this is our cos, cos, sine, sine, opposite. Now we just have to find the values for pi fourths and pi thirds. So let's sketch a little unit circle here to help us out. So pi fourths is up here, and that's going to have coordinates root 2 over 2, root 2 over 2. And then pi thirds is up here, and that's going to have coordinates 1/2 root 3 over 2. Remember that cosine is our x value, sine is our y value on our unit circle. So now we just pick up those coordinates. So the x values come first. Cosine of pi fourths is root 2 over 2. Cosine of pi thirds is 1/2. Sine of pi fourths, so the y values, is root 2 over 2. And sine of pi thirds is root 3 over 2. When I multiply these fractions out, I'm going to get root 2 over 4 minus root 6 over 4. So that's going to combine to be root 2 minus root 6 all over 4. And we can leave our answer just like that. So there you go. That's how we can use a sum or difference formula to help us find an angle or a cosine of an angle that isn't one of the special ones on our unit circle. Now, I do want to show you that there are multiple ways that you can do this. There's nothing super magic about 3 pi 12ths and 4 pi 12ths in terms of needing to use those two in order to figure this one out. For example, if I had 9 pi over 12, I could get 7 pi over 12 by subtracting 2 pi over 12. Right? Since 9 minus 2 will give me 7. But both of these will also reduce. 9 pi over 12 will reduce to 3 pi fourths, and 2 pi over 12 will reduce to pi over 6. So just to show that we could have used a different combination, let's go ahead and apply a difference formula for this one and see if we get the same answer. So let's see if we get there in the end. So we could have rewritten cosine of 7 pi over 12 as cosine of 3 pi fourths minus pi 6. This is still a cosine difference formula, so it's still going to be the same process, cos, sine, sine, opposite. So we're going to have cosine of 3 pi over 4, cosine of pi over 6, sine of 3 pi over 4, sine of pi over 6, and then the opposite of subtraction is going to be addition. Now this time, because we have different angles, let's draw a different unit circle for reference. So I'll draw that down over here. So this time I want to find 3 pi over 4 and pi over 6. So pi over 6 is going to have the coordinates root 3 over 2 and a half. 3 pi over 4 is going to have the coordinates negative root 2 over 2, positive root 2 over 2. So let's see if we're going to end up getting the same answer. So cosine of 3 pi fourths is negative root 2 over 2. Cosine of pi over 6 is root 3 over 2. Sine of 3 pi fourths is root 2 over 2. And sine of pi 6 is 1/2. So we'll get negative root 6 over 4 plus root 2 over 4, which will combine to give us a positive root 2 minus root 6 all over 4. So there you go, that works as well. So you can use either a sum or a difference in order to find this result. The goal is you want to find fractions that are going to relate or simplify to fractions we know about. So this is one type of sum or difference formula question that we can see. Let's take a moment and look at a second type that we're going to be seeing. All right, so whereas our previous example related back to the unit circle and angles that we knew stuff about, this example here is going to relate back to those examples where it was, we know like sine of theta, let's figure out cosine of theta using identities or properties. So for this example, we need to figure out what sine of theta minus phi is going to be. When sine of theta is 2/3, cosine of phi is negative 2/5. And then we know information about the quadrants where those angles live. So in the big picture, we can see that we're going to need a difference formula for sine because we have a difference of 2 angles here. And our difference formula for sine is going to be sine, cosine, cosine. So we're going to need to know sine and cosine for both angles. So when I'm going to attack a problem like this, I'm going to basically make like a list off on the side. I need to know sine of theta, and I need to know cosine of theta, and I need to know sine of phi, and I need to know cosine of phi. Once I have those 4 values, then I'm going to be able to find sine of theta minus phi. So I'm going to fill in what we know. We know that sine is 2/3. Sine of theta is 2/3. And we know that cosine of phi is negative 2/5. So here's where we're going to relate back to those techniques of using either trig definitions or trig identities to find the missing trig expression. I'm going to use trig identities here because ultimately we're going to want to be pretty fluid with these identities, and we're going to kind of be drifting away from the definitions a little bit. If you're still more comfortable using the definitions, you can feel free to do those and then like as a check for this, but I encourage you to practice with your identities because next week we're going to be needing those identities at the ready. So you want to practice with them. So we have sine of 2/3 and they're telling us what quadrants we're living in here. So we're between negative pi halves and pi halves. So negative pi halves is down here and positive pi halves is up here. So we're living in either the first or the fourth quadrant. Since sine is positive, that means we're living up in this top quadrant here. So this is useful for us because this means that cosine of theta is going to be a positive value. I like to use the Pythagorean identity to find my missing cosine. So I'm going to do cosine squared theta plus sine squared theta is 1. So cosine squared theta plus 2/3 squared is 1. So cosine squared theta plus 4/9 is 1. So cosine squared theta is going to be 5/9. So if we subtract 4/9 from both sides, we get 5/9. Then we're going to square root. So we get cosine of theta is plus or minus the square root of 5/9. Now we know because we're in quadrant 1, we want the positive square root. And because we're taking the square root of a fraction, we can square root the numerator and square root the denominator. So this is going to be a positive √5/3. So we now have cosine of theta, so I'm going to fill that in on my list over here. Positive √5/3. Now we're going to repeat this process for sine of phi. So we have cosine of phi. We have some information about what quadrants we're living in, and we can use that to help us figure out what sine of phi is going to be. So if you want to practice finding that on your own, I recommend you pause the video here, practice finding that, and then you can unpause and we'll go through it together. All right, so let's see how we did. So I'm going to use the same Pythagorean identity. So we're going to have cosine squared phi plus sine squared phi is equal to 1. And let me figure out whether I'm going to need a positive or negative. So this is telling me I'm in the northern hemisphere because I'm between 0 and 1. So I'm either in the first or the second quadrant. Cosine is a negative value, so that means we're going to be in quadrant 2 because that's where cosine is negative of those two. So we're going to be in quadrant 2, so that means sine is going to be positive. So I'm going to fill in negative 2/5 squared plus sine squared phi is 1. So 4/25 plus sine squared phi is 1. This means that sine squared phi is going to have to be, is that 21/25? So sine of phi will be plus or minus the square root of 21/25. Because we're up in quadrant 2, we want the positive. And then this will be √21/5. So sine of phi is going to be the square root of 21/5. All right, so how did we do? Did we find sine of phi okay when we practiced? So now let's go ahead and find what we need to find. So really what used to be like one problem, we've now done twice, and we haven't even gotten to the heart of the matter yet, right? We need to find the difference or the sign of these difference. So let's give ourselves some space here to do that. It's also why I like having this on the side here. It's easy to reference and I can kind of clear space as needed. Now for sine of a difference, that's where it's going to be sine, cosine, cosine. So sine of theta minus phi is going to be sine cos. So sine cos. Keep those angles in the same order. Then we're going to have another sine cos, and now you reverse the angles. Okay, so we have theta phi and then phi theta. And then it's the same operation. So sine, cosine, cosine. Now we just substitute in the values that we were given and that we worked so hard to find. So sine of theta is 2/3. Cosine of phi is negative 2/5. Sine of phi is √21/5. And cosine of theta is √5/3. So over here on the left, we're going to get a negative 4/15. Ugh. So 5 times 21 is going to give me the square root of 105. and we have 15. So we could have -4 minus root 105 over 15. And you can leave your answer like that if you wish. If you want to factor a negative out of the numerator, you can as well. And you could write that as negative, and then the fraction 4 plus root 105 over 15. So either of these answers would be acceptable for this problem. All right, so that's going to conclude our video on sum and difference formulas for sine and cosine. So we've gone through two different types, one that relies on our previous knowledge of the unit circle, and one that relies on our previous knowledge of using one trig information to find another one. In the next video, we're going to be looking at double angle formulas and applying those in a similar manner. So I'm looking forward to seeing you then. I hope you found this video helpful in remembering and applying the sum and difference formulas. And I hope you have a wonderful day. Bye for now.